Welcome back to the Explainer, everyone. Today we're setting our sights on the night sky to look at one of the absolute coolest visual spectacles the universe has to offer, the lunar eclipse. Now, right off the bat, I want to give a huge shout out to Dr. Masood Awan, whose incredible research helped shape this explainer. We're going to use some awesome 3D models and show you the absolute best pictures, wherever possible, to take you on a journey from the raw orbital mechanics of our solar system all the way to that cosmic visual magic you can see right from your own backyard. Okay, let's just dive right in. Here's our roadmap for today. 1. The cosmic dance. 2. Anatomy of Earth's shadow. 3. The 3 eclipse types. 4. Why the moon turns red. And 5. A fading cosmic spectacle. Starting us off with Section 1. The cosmic dance, aligning the sun, earth, and moon. To really wrap our heads around eclipses, we have to appreciate that it's all about perfect cosmic geometry. Simply put, a lunar eclipse is a cosmic event that happens when the Earth directly intervenes, blocking some or all of the sun's direct light from reaching the lunar surface. And, as you might already know, this massive shadow play only ever takes place during a full moon. That specific phase is an absolute, strict prerequisite for the Earth to squeeze right in the middle of the sun and our lunar neighbor. Which brings us to a really crucial number, 29.5. It takes exactly 29.5 days for the moon to complete one full orbit around the Earth. That's the fundamental rhythm of our night sky, right? And because of that 29.5-day cycle, we're treated to a full moon roughly once a month, every single month. But that naturally begs an obvious question. If a lunar eclipse happens during a full moon, and we get a full moon every 29.5 days, well, why don't we have an eclipse every single month? I mean, why isn't this just a regular monthly event? It kind of seems like it should be, doesn't it?
Well, here's the crucial point. And if you imagine that 3D model we talked about earlier, it really helps visualize this. Space is incredibly three-dimensional. The moon's orbit is actually tilted just a few degrees in relation to the Earth's orbit around the sun, so they aren't just sliding around on a perfectly flat tabletop. Because of that slight tilt, perfect alignment is actually pretty rare. Most months, the moon passes just a little bit above or a little bit below the Earth's shadow and completely misses an eclipse.
Moving on to Section 2, Anatomy of Earth's shadow, penumbra and umbra. So when that rare alignment actually does happen, the Earth doesn't just block the light evenly. It actually casts two very distinct types of shadows out into the void. First, we have the penumbra. That's the larger, outer, more diffuse shadow. And then, nestled right inside of that is the umbra, a much smaller but significantly darker inner shadow. Honestly, understanding the difference between these two shadows is the absolute key to understanding what kind of eclipse we end up seeing from the ground. Which takes us to Section 3, the 3 eclipse types: total, partial, and penumbral. Depending on exactly how the moon moves through those two distinct shadows we just talked about, we get 3 completely different visual experiences. The first, and undoubtedly the most famous, is the total lunar eclipse. I mean, this is the jackpot. It happens when the sun, moon, and Earth are in absolutely perfect alignment, and the moon falls entirely within the Earth's darkest umbral shadow. These are hands down the most striking of the 3 types because this perfect umbral alignment does something truly magical. It turns the moon a gorgeous, deep sunset red. But what if the alignment is just a little bit off? Well, that gives us our second type, the partial lunar eclipse. Here, the celestial bodies don't perfectly align, meaning only a portion of the moon passes into the Earth's dark umbra. When you look up during a partial eclipse, the Earth's shadow appears incredibly dark, but only on the specific side of the moon facing the Earth. It literally looks like a giant cosmic bite has been taken right out of the moon's bright surface. And the final type is the penumbral lunar eclipse. In this scenario, the moon completely misses that dark umbra center and passes only through the Earth's lighter, outer penumbral shadow. Honestly, guys, this event is incredibly subtle. The moon will appear just slightly darker than normal. In fact, it's so slight that most people casually looking up at the sky wouldn't even notice it's happening at all. All right, Section 4. Why the moon turns red, the science of the glow. Now, this is fascinating. If the Earth is completely blocking the sun's direct light during a total eclipse, why doesn't the moon just go pitch black? Why does it turn that iconic sunset red? Well, it's because our own atmosphere acts like a giant cosmic filter. Sunlight is made up of all the colors of the rainbow, right? So when that light hits the edges of the Earth, our atmosphere scatters the shorter blue wavelengths of light outward, just bouncing them away into space. But the longer red wavelengths behave differently. They're refracted or literally bent inward by our atmosphere, funneling directly toward the moon. Basically, all the sunrises and sunsets happening on Earth simultaneously are projecting their red light straight onto the lunar surface. How cool is that? But that red glow isn't always the exact same shade. Because this light is filtering through the Earth's atmosphere, earthly conditions essentially act as the paint on the moon's canvas. The brightness and color depend heavily on the amount of dust in our atmosphere and the cloud cover at the time. Most dramatically, if there's been recent heavy volcanic activity, the ash in the atmosphere can block out enough of that bending light to render the moon a much darker, bloody red, or sometimes even almost entirely black. So yeah, Earth's weather literally controls the moon's wardrobe. Real quick, before we move on, I do want to touch on an important viewing distinction. Many of us know that during a solar eclipse, it is completely unsafe to look at the event directly without specialized eye protection. But a lunar eclipse is the exact opposite. Because you're simply looking at sunlight bouncing off the moon, just like a normal full moon, only dimmer and redder, it is perfectly safe to view a lunar eclipse with the naked eye. No special glasses required whatsoever. And you actually have a pretty decent chance of catching one. Lunar eclipses occur up to 3 times a year. And the best part is really their sheer accessibility. Unlike a solar eclipse, which only sweeps across a tiny, narrow path on the globe, a lunar eclipse can be observed by the entire nighttime half of the Earth simultaneously. So, if the moon is up in your sky while the eclipse is happening, you've automatically got a front row seat. Bring this to our final section, Section 5, a fading cosmic spectacle, the moon's retreat. So while we can easily step outside and enjoy this today, the rules of this cosmic dance are actually very slowly shifting. We only witness total eclipses because of the precise current distances of the sun and the moon from the Earth. The geometry that makes our umbral shadow exactly large enough to swallow the moon is entirely temporary. You see, the moon isn't perfectly stationary in its orbit. Due to the physics of our tidal interactions, the moon is actually inching away from the Earth every single year. And when you stretch that inching process out over billions of years from now, the math changes completely. Eventually, the moon will simply be too far away from the Earth to ever fall completely within our dark umbral shadow again. The Earth's shadow cone will just taper off before it ever has the chance to fully wrap around the retreating moon. Which leaves us with this final, somewhat provocative thought. How many more total eclipses will humanity witness before the largest object in our night sky outgrows our shadow forever? We are living in a highly privileged window of cosmic time, where the distances and alignments are exactly right to give us this stunning visual treat. So the next time the Earth, Sun, and Moon perform this delicate cosmic dance, make sure you step outside, look up, and appreciate the fleeting magic of our own planet's shadow while it still reaches.